In today's agenda, we will be discussing on monitoring your application's response time and calculating the end user satisfaction based upon the user transactions and studying the transactions which are causing slowness to your application. And we can drill down to the SQL statements and see what specific SQL queries have causing the issue. And also, we will be discussing on the identifying the application's traces for the specific error transaction and isolate errors. Let's get started. And before we get into the today's topic, let's take a sample web application architecture. As you could see in this picture, a web application is built using multiple components like a web server and a web app component and a DB server. So all these components were integrated with each other and they talk with each other to keep your applications up and running. In case if any of these component goes down, that's where you have an issue with your application performance. Say for example, if your DB, which is used by your application, is down, in that specific case, you may be having an issue with the application. So it's crucial to monitor end-to-end components of your application. And that's what we'll be discussing on today, focusing on application performance management. So administrators, if you're a network administrator or an application administrator, definitely you'll be using multiple monitoring tools to monitor your application. You might be using a single tool for monitoring your database, and you might be using another tool for keeping a track on your application performance management. So Managed Engine Application Manager helps you to overcome that specific problem. Instead of switching back to multiple tools and fetching the reports separately from different tools creates a lot of hurdles in terms of management. So Applications Manager is a single tool which gives you more comprehensive information of your app performance. So let's see the common reason for your application slowness. If your web server is overloaded with too many requests from the users, say for example, whenever a user sends a request from their browser, the request reaches the web server, wherein the web server responds back with the content requested by the user. So if the web server is too much overloaded, that's where you have a problem with that. So that's what we call it as request overload. Similarly, there could be an issue with the database, and the issue might occur due to multiple reasons, probably improper schema design and slowness. If the query is not optimized properly for any reports, that's the case where you might have an issue with your database, and buggy application code. So that's also one of the primary reason for your application slowness. So your application, which is developed in a small data set, probably when your application is developed, you might have tested with a small data set. However, when your application is rolled out to the production, that's where the actual playground happens. And it is crucial to monitor your application in terms of production and end user based perspective. As we all know that the applications nowadays is no more traditional, and it uses complex distributed systems, and it is using an hybrid cloud based systems as well. So it is crucial to monitor your specific application end to end. And again, improper memory management with specific to your application again leads to the application slowness. And also we know that the threads configuration play a crucial role here. If there are more number of stuck threads, that's where again your application may not be able to respond back to the user request, and it may have performance or stability issue. Let's take a look at the common metrics which is required in terms of application performance monitoring. That is the KPIs for APM management. So when talking about the application performance management, these are all the key metrics as you could see here in this presentation: response time, transaction traces. So what do we mean by response time? Is it's quite straightforward. How much time it takes for your application to deliver back with the content requested by the user. So that's the straightforward factor which needs crucial monitoring. And transaction traces. So every a transaction definitely will not be optimal. So in those cases, you could see the transaction or analyze the traces for a specific transaction where the response time is high, and the error traces again, and source SQL statements. Of course, all the transaction, whichever is happening inside your application, will be having an equivalent SQL statement. Say, for example, whenever a user is logging in, there is a backend SQL query which is getting fired with the username and password. Either it could be an update statement or something. So, in that specific case, understanding the SQL statement is crucial. And again, Apdex score. We will be discussing more on these components in the upcoming slides. So before we discuss about this, let's see the supported technologies in APM Insight. So our solution, that is APM Insight, is an agent-based solution. So we support monitoring of three different types of frameworks. That is, it could be a Java-based application, .NET, and Ruby on Rails. And in the near future, we will be supporting PHP, Node.js, and .NET Core applications as well. So let's see, as this is going to be an agent-based solution which collects the comprehensive information of your application performance. Let's see how the data collection happens using the APM Insight. This APM Insight agent is deployed in the web server or in your application server where your app is actually hosted. So this agent hooks up with the process of your web application server or web server. It collects the data every 1 minute and push the data back to the applications manager. And the application manager web server receives the data and interpret that data in the APM Insight. So we use a specific method called bytecode instrumentation to fetch this information. So this is quite straightforward as such. So after deploying the agent, you may have to restart your application server so that the agent can hook up with the specific process. So we'll discuss, and I'll give you a more hands-on experience in terms of deploying the agent. So let's see how you can optimize your application response time to deliver a rich set of user satisfaction. So APM Insight provides you a whole new dimension of your web application performance and deeper insight to optimize your application by finding the performance related bottlenecks, if there is any, and the exceptions, and why the exception is occurring. Identify the slow query, and not only identify, you can address those inefficiencies by using the stack traces. So this APM Insight acts as a DevOps and hybrid tool in terms of applications management. So this is going to be the dashboard of APM Insight. And once the data is collected, you could see multiple values right here. And each value represents a specific set of data. So as I mentioned to you earlier, when performance anomalies are detected, this APM Insight agent automatically captures the transaction snapshot and you could see all the data in a single pane of glass. And you could also see the correlation between your application performance along with the behavior of the end user transactions, thus by enabling you to quickly identify the root cause of an issue, and if there is any issue, visualize those transactions and see how it is impacting your end users, so that you can provide a flawless customer user experience. So let's see the common metrics which we use here and which would be quite helpful for you in terms of monitoring. The first key metric is Apdex score, which is called as Application Performance Index Score. This is an open standard for measuring your application satisfaction, and it's a metric that provides you complete details of your application. So that is, the zero shows that no user satisfied, and one says that all the users were satisfied with the performance of your web application. Thus, by giving the business application owners an insight into the measure of how your application is performing, and gives you clear information of the end user customer happiness and satisfaction levels, so that the concerned business stakeholders can ensure all the specific transactions is happening properly. And if there is any issue with any specific set of transactions, it can be analyzed using the suggestions shown in the APM Insight with the help of your developers. So understanding this impact definitely plays a crucial role in terms of building a successful business. So as nowadays, all we know that most of the websites are becoming online and all the transactions is happening via online. So uh, due to large number of data set and increased number of traffic, the application is becoming more complex. So it is crucial to keep a track on the individual components like web transaction and see what exactly happening. So let's take a look at the response time of your application and the throughput, how this information will be helpful in terms of managing your application. So the response time is the commonly and most widely used metric, which gives you direct measure of how long it takes for your application to process a request. And again, throughput, again, a straightforward count on the number of requests that your application can process within a defined time interval. So understanding how much traffic your application receives will help you to plan the capacity accordingly. So in case if your web application is receiving high number of load in a specific time, that's where you can use an efficient load balancers to split the load across multiple web servers. The more user requests your web server is receiving, higher the load is, and based upon that you can see the data. Let's see the next topic for today, that is pinpointing the transactions that are causing slowness to your application. So how do we calculate the specific transactions which are causing slowness? It is straightforward. It is based upon the response time. If the response time for a specific transaction is slow, we treat that as a slow transaction. And we show you in the dashboard. And we give you, you can drill down to the specific transaction and see what exactly is happening inside a specific transaction and perform remedial action using these suggestions. So also, we could see the transaction component split up. So what do we mean by transaction component split up? So whenever a business transaction is occurring, it is made up of all the required services within your environment that are called upon to fulfill a specific user request. Example could be a login, as I mentioned. It could be a search operation performed inside the application, or it could be a checkout if it is an e-commerce based application. So there would be multiple web application, web services, third-party APIs, and databases were involved in these transactions. So we show you the component-wise split up in the specific transaction, which will help you to understand how the application is behaving and how the components is being split up. Say, for example, if you see a specific transaction which shows you that 70% is consumed by the database itself, that's where you have to take some action. So in that specific case, if 70% is consumed by the database, so that's where you might have a load, you might have an increased load with the database. So if you could drill down and see, in those cases you can optimize those query, or you can enable the caching. So there are multiple kind of optimization can be done using that specific results. So I'll give you more detailed information once we get into that specific topic. Also, you can see the transaction element wise response times. So not only we show you a common Apdex score for the overall web application performance, there could be a specific transaction which is quite important for you. If you're running an e-commerce business, the payments checkout could be quite crucial in terms of specific e-commerce business owners. And also you could have a dependency with the payment systems from a different websites, wherein you might be using an API from the different site. So in those cases, you could see how the transaction is performing and again analyze those transaction when it is completed and see the internal code invocations. We'll be discussing that. So let me switch back to the UI and give you a more hands-on approach with what we have discussed until now. So let me switch back to the applications manager product, and we are in the UI now. So you will be finding a specific tab right here called APM Insight, which is a dedicated module for managing your applications. So let me show you the first step towards monitoring your application. So you will be having a help card page like this, and you could use this option, download and install the APM Insight agent, and then you will be redirected to our website, and you could depending upon your application. If you're using a Java-based application, you can download this agent and get started. So once it is downloaded, so let me show you the next step towards configuring. So once it is downloaded, you should be you can unzip that specific agent file, and you should be having multiple files inside. And all you have to do is edit this APM Insight.conf file, and the entries which you need to add is, let me show that to you. And you have to specify the APM host. So you have to move the specific agent file to the application server running machine, and you have to provide the APM machine IP address. That is the machine IP address where the application manager is installed. You can provide that, and in the apm.port field, you can specify the actual port of APM. That is 9090 for HTTP and 8443 for HTTPS. So this is, once you specify this detail, now the agent knows where to push the data. So now the other step is how the agent will collect the data and how the agent will talk with your application server process. So for that, you have to add the agent path. So the link for configuring the Java agent will be shared in the webinar chat panel. So all you have to do is you have to change your configuration. You have to add this specific entry in the web server configuration file. It could be a startup file or any file, and you can just add it and restart your web server, not the complete server, just your web server. You can just restart the service. So once it is done, this agent hooks up with the server process, and then you can fetch the data. So once it hooks up with the application server process, it collects the data and push back the data to the APM Insight. So once the application manager receives the data from the agent, this is how the data looks like. So here you can find the Apdex score, as I mentioned you. And again, you could see the split up of the Apdex score. That is 99.3% of the users, whoever is accessing this application, were happy with the performance, and 0.3% is tolerating, and 0.3% is frustrated. And you could see the average response time, which is crucial again, and throughput information, and the request count received by this web server from the user. So if you have any question, please feel free to ask that in the webinar chat panel. Our expert panelists will be able to answer those questions. And in case if someone is looking for more personalized demo, please feel free to express your interest in the survey, which will be rolled out. And you could see the Apdex curve along with the average response time, and the average response time broken by its tiers. That is, since in this specific case, I'm trying to monitor applications manager itself. So app manager itself, a Java-based web application, which is built on top of Apache Tomcat server. So I have deployed this agent in the applications manager server machine, and it collects data and it pushes back the data. And you could see the throughput information. So other important categories, slow transactions, and we show you those slow transactions, and you can drill down to the specific transaction and see the data. And apart from that, you could see the top 5 transactions, which is again based upon the response time. So with this, let me switch back to the UI presentation and give you more details on how to find the specific SQL statements which is causing slowness to your web application. So we are in the presentation now. So this is going to be the third topic of today's agenda, where we'll be looking more in terms of database perspective and the database queries which is causing slowness, and the other metrics which needs to be monitored in terms of DB calls. So using the APM Insight, you can find the queries which is creating delayness in terms of response time. So these enterprise applications rely on multiple components that interact or in a more complicated and sometimes unpredictable ways. So these additional layers making it difficult for an administrator to isolate the root cause whenever a problem occurs. So in a traditional way, an administrator may try to reproduce the issue in their environment. Sometimes may be successful and it may not be successful every time. So implementing a tool like APM Insight will definitely help the DevOps or the application owners to understand how where the issue is occurring and what to be done when an issue is occurring. And we show you the slow database calls, which is very specific to the application's DB. So you could see the most hit database by, as you could see in the specific screenshot, and determine a specific table, which is in case if a specific table is overloaded with a high number of rows, and if it requires an indexing, yes, you can do it for. But by this way, you could fine tune your application performance, and also you could tune your database performance and diagnose the slow queries. Using the SQL query execution plan, you can definitely optimize those queries. And Applications Manager Insight gives you the comprehensive performance of your database. That is, all the DB calls, whichever is happening inside your web application, will be shown with its response time versus the throughput graphical information. And you could also see the individual DB calls. So you could find the most executed DB operation and its response time, the DB operation by its call value, and find the most performed SQL operation on the table. So apart from this, there are chances that the DB server might be used for other applications also or tasks. So it is important to monitor the DB server itself in terms of DBA's perspective. In more. So now until now we have discussed the monitoring in terms of DevOps and application teams perspective. So going forward, we will be discussing more in terms of DBS perspective. So before we discuss about that, let me switch back to the Applications Manager Web Console and show you the DB call details in the APM Insight panel. So we are in the App Manager UI now. So as I mentioned earlier, we capture all the transactions happening inside your web application and give you the Apdex score for the individual transactions and throughput information, and the DB calls whichever your application is receiving. Along with that, you could sort these values based upon 4 values like average response time, throughput, most time consuming, error details. So you could see the response time in millisecond, and when you click that specific transaction there, that is the DB call, you could find those operations right here on the right hand side, and you could find the DB operation response time versus throughput. So this is about the DB calls with specific to your application. So let me switch back to the presentation and discuss in terms of DBA monitoring perspective. So let's see the common database problems which occurs in a production-based setup, and how to tackle them by using a monitoring solution. So database monitoring is a critical part of any application infrastructure, or in terms of maintenance task as well. So finding these issues in time will definitely help you to prevent critical production issues. So by this way, you can implement proactive monitoring for the components. Let's see what needs to be monitored in a more common perspective. So the first is database response slow towards a specific request. Second, not able to retrieve data when accessing a particular record in a web application. So let's discuss what to be done in terms of if your database response is slow towards a specific request and what metrics needs to be monitored for this specific use case. So slow response from your DB server could be because of multiple reasons, and the primary reason would be not enough resources to handle the specific request, or the query could take more time to execute. So now let's see what are all the metrics one can monitor to keep a tab on resources and queries. So monitoring the availability and resource consumption will definitely give you a clear glimpse of what exactly is happening and how whether your database can serve the future request. And the next step towards the basic proactive monitoring would be to check whether all your database or table space, whether it's an online at regular intervals, And this should be done during your business and non-business hours also, and you can compare the data between those to find the overloaded table space or overloaded databases as well. It is the most basic and important test. So let's take a look at the buffer manager statistics. If you ask any DBAs, they will anyways prefer for buffer manager monitoring. That is the statistics of the buffer manager. So it is important to monitor the buffer and cache hit ratio, page life expectancy, cache used per minute. So the buffer cache hit ratio counter represents how often the SQL Server is able to find the data pages in the buffer cache. So when a query needs a data page. So the higher the number, it is better. So it is always, as a DBA, someone needs to ensure that the buffer memory is always high. And because it means SQL Server was able to get the data, right? So the page life expectancy is again another counter which could measure how long the page can stay in the buffer cache. So this is again another important factor. And cache hit ratio gives you more detail of how your planned cache is being used. Higher the percentages, that means your SQL Server is building a specific query. So let's take a look at the next slide. And here we will be analyzing or say we will be discussing on monitoring your log file and data file specific to the SQL Server. When you create a database in the SQL Server, data files and transaction log files are automatically created. So the data file holds the data and objects such as tables, indexes. It could be a stored procedure. The transaction log files records all the transactions and the database modifications made by each transaction. So it is important to monitor those transaction log files, and as it contains the crucial information like which is required to recover all the transactions in the database. And again, it is important to keep an eye on the log file size as well. So say, let me just give you a use case, how it would be useful in terms of production and a complex setup. Say, for example, you know that your database file size would grow over a certain period of time as the transaction is increasing over a certain period of time. So in those cases, you can perform automation using the applications manager. So this tool not only acts as an monitoring tool, in term it acts more than that by performing automation and orchestration. That is, you could perform few remedial action using the tool whenever a specific alarm is generated. So say for an example, you associate a specific, say for example, if your DB size for the production DB is the consuming memory is 95% and you just have 5% of less memory. So in those specific case, you may want to shrink your database, which is the manual activity that DBA will be doing. So in those case, what one can do is they can just create a threshold. So whenever the 95% is violated, we raise an alarm. So whenever an alarm is raised, there is an action, there's a workflow activity that can be attached. So all you have to do is you can create an execute program action and just point your shell or back script inside it. And you need to create a script in such a way that it creates a shrink command. So once we generate an alarm, this execute program action will be raised. As a result, you can automatically shrink the database. So this is just a basic understanding I have provided. In fact, can you can in fact perform few complex automation as well, which is highly customizable based upon your business requirements. So let me switch back to the next slide. And similar to the database in the MS SQL Server, an Oracle definitely has a table space statistics, and it's important to monitor the table space again, whether your table space is online and whether you're measuring the IO ops of your table space definitely gives some more information. So these table space can stores this information. It's a logical storage unit which collectively store all of the data. So each table space in an Oracle database could consist of one or more data files, so which are treated as a physical structures in terms of operating system. Hence, you need to monitor these table space. And let's discuss on the few metrics which is required in terms of tablespace monitoring. That is like monitoring the reads and writes, tracking the data files, and you might be implemented an auto extend. So it is important to keep an eye on those specific factors as well. And MS SQL top queries by CPU. So we all know that high CPU usage is definitely a common problem in terms of SQL servers. Any query with a bad query plan can steal the CPU time and can harm the CPU response time. So in those specific cases, application manager gives you the top queries, which is based on high CPU usage. And since we provide you a complete set of query itself, you can take that query and use it in the SQL Server execution planner and optimize or fine tune the query. Also, you can use any query optimizer or advisor to fine tune your queries, thus by delivering fine tune your app performance. So these are all the details which we show here in terms of top queries as well. You could see the query details and in which DB that specific query is running, the last execution time, average execution time, and the total CPU time of the specific query. And again, the slow running queries, which is based upon the execution time. So we show you the query detail along with the number of execution, min, max, and average execution time in milliseconds. So Oracle buffer gates, again, this is based upon top 10 queries. So we give you the information about the buffer gates execution, buffer gates per execution. So just a basic idea of what do we mean by buffer gates. The SQL DBS will be knowing about it. When an Oracle requires a data block, it first check to see if the data block is already in the memory. So database buffer cache, that's what. If the data block is found there, Oracle will read it. So this process is called as buffer gates. So it is crucial to monitor the specific component in terms of query monitoring. That is Oracle buffer gates, top 10 queries. And you could see the SQL ID along with the query, along with the buffer gates per execution value. And Oracle disk reads is other important factor in terms of production DB monitoring. So if the data block is not found, Oracle will again need to bring back the data block from the disk, the buffer cache first. This process is called as disk read. So you could see that in the screenshot, disk read is 14 and the execution is 1. So this gives you clear information of what exactly is happening inside in terms of IO ops perspective. So when the IO workload increase, that's where you might have a performance related bottleneck when accessing a specific table with large number of data. Say assume that a user would like to get data from a specific table inside a DB, and it is taking a large time for him to get the data. The reason could be due to high number of discretes, which is consuming high IO operation. So there is a chain of activity which is happening. So this is what required in terms of proactive monitoring. So combining these metrics will give you a clear information of how your DB is performing. Let's see the next set of scenario, that is unable to retrieve the data while accessing a record. So what details to analyze? Say for example, if one is fetching the data and he is not able to get the data. The details to be analyzed is session, waits, log information, and block queries information. So these details were common for the MS SQL and Oracle DB servers. So let's dig deep into this and find the common reasons and how we can set up a proactive monitoring for this. So as a first step, let's see the MS SQL session details. So we display the SQL Server session ID running in the SQL Server along with its status. And this SQL session is an occurrence of a user interacting with the database through the use of SQL commands. So whenever the user initially connects to the database, we know that a session is established. So it is important to monitor the number of connections per host as well as the process ID, which is consuming high CPU or memory usage. So when again, when locks are held for a longer time, they may cause blocking. Say for example, which means one process has to wait for the other process to finish. It's a kind of queue activity. So once the queue is cleared, the next process will get activated. So similarly, some once the process is completed, the lock will be released. So identifying the blocked session is an important metric. And if needed, one can kill the session directly from the applications manager itself, wherein we provide an option called kill, which is highlighted in blue color. So similar to the MS SQL, Oracle database definitely has a session, and you can identify the online, offline, or invalid sessions initiated by the users, and monitor the number of memory sorts and table scans performed. And we can also track the physical and logical reads of the session, as well as the buffer cache ratio information. So a basic information about the scan. So a table scan is where that this occurs whenever the your user requests a data and indexing happens to find an appropriate records in case if the data requested is high. So the reason you might want to find and fix your scans is because that generally require more IO and takes long time to process. This is something that you will notice with an application that grows over a period of time. So when it is first released, the performance would be great, but over time, as the time grows, more data is added and the indexing scans again takes longer time to process. So tracking these physical and logical reads along with the buffer cache will definitely help you to reduce those kind of problems. And next, see the session summary details, and you could see the session's wait time and its corresponding event, the account status, and the user account expiry date. So we discover, automatically the users present inside the Oracle database, and you could see a specific column right here called days to expiry. So say for example, you have created a user and the password is the user account is going to expire on so and so date. You can configure alarm for this specific column and can receive proactive notification from the tool. This is just one of the basic example that I have provided. And again, MS SQL top waits by waiting task. So what do we mean by wait right there? A resource wait is actually accumulated by the process running on SQL Server, which are waiting for a specific resource to become available, such as waiting for the release of a lock on a specific record. So this could be one of the statement. Or also, these categories could be wait, type, and multiple types were in fact available. So in case if there is any schema level issue, locking issue or plan cache pressure, which cause the IVR problems, that could in fact result in the waiting task. So this we give you a clear information of the waiting task along with the wait time and the average wait time. And MS SQL most blocked queries. So imposing the lock over an object will cause other process to impose that request back again. So this is what it is called as the blocked queries. So with this, I will move to the next slide and discuss about the logs in terms of Oracle perspective. So these logs, again, it acts as a destructive interaction between the transactions, whichever is accessing the same resources. So the database maintain multiple types of logs depending upon the operation that is acquired. In general, it is two types of logs, exclusive log and inclusive logs. So let me switch back to the Applications Manager web console and show you the data required. So let me choose the Monitors tab, and we have this option called Oracle, and let's see the details which we have discussed. So as I've given you an information about in the presentation, we monitor the complete DB server in an end-to-end perspective. So if, for example, we discover the table spaces present inside the Oracle database and we start monitoring of it. And there are multiple columns that you could see here. So percentage of used bytes This is again one of the important columns that one can configure alarm, and you can again compare these table spaces with one another with the metrics available on this site. Also, the current status of the table spaces and including the IO ops, that is the read time and write time information, whether the table space is online or if you have enabled auto extend, you could find out information in the performance of data files, and you could see the reads, writes, and the data file name information with its complete path, and you could see the table space name which is attached to a specific data file. So similar to that, you could see the session details. We monitor all the sessions connected to the specific DB server from your user, and we show you the session ID, the status of the specific session, from which machine the session is being accessed, and the table scans, CPU used, physical reads, and logical reads, including the buffer cache hit ratio for the specific individual session wise. So you could find those details, and including the session summary and the session weight. So here we give you the session weights along with the ID of those sessions and how much time the session is waiting. So as you could see here that this specific session is in wait for more than so and so seconds. You could find those events and the number of event occurrence for the specific sessions and the user based information along with the days to expiry for the specific users. And here you could see the buffer gets along with the top 10 queries. So this is what we have discussed in the presentation. So we show you the complete query along with the SQL ID, the buffer gets per execution value, along with the buffer gets and the total number of executions happened. Say, for example, if you suspect that the query is being executed multiple times in a specific web application. So in those cases, you could introduce caching to reduce the query execution. So this is one of the way that one can perform to optimize or fine tune your SQL Server performance or your app performance. So let me go back to the SQL Server and let's talk about the metrics involved in terms of SQL DBS perspective. And let's take one of the pre-production SQL Server, and right here you have a specific tab called performance. So we have multiple values wherein you could see the top queries by CPU by just clicking this and see the query in a complete details, and you could see the CPU time and CPU time, average CPU time in millisecond and average execution time in milliseconds, along with the DB where the query is actually being executed. And apart from this, you could see the top slow running queries and configure alarms for the same, and perform automation activities to fine tune your application. You could use, there are numerous number of tools or query optimizer tools available like Todd, so which you can use it for delivering a rich set of user experience. And you could see the cost of missing indexes in terms of previous perspective, and the most blocked queries information right here, along with the average time blocked, total time blocked, and average execution time, along with the DB name where the query is being actually executed. So with this, I will switch back to the presentation again and discuss the final topic for today. So now we are back to the application performance management, and we can see how you can analyze the traces and isolate errors. This is the most crucial part in terms of solving the errors. So earlier we have seen you can monitor the metrics, and you could get an alarms, you could perform your automation. So this is more for in terms of developers perspective. So you could pinpoint the specific transaction which is causing slowness. That is, you could understand, uh, we show you the traces. You could drill down to a specific trace and find in which method the issue is being occurring. So as in a common programming term, there could be multiple methods inside your web programming code, and each method is being called by a multiple level of functionalities, and there could be an objects, classes, and the objects as well. So we show you the traces to investigate those time consuming transaction, and you can drill down to see the internal code invocation. When a method is called, what exactly happens in the subsequent line of code is being printed, and you could see those values right here. And you could see the trace details in a more clear fashion and SQL statements in a parameterized way. And also, there in a few cases there could be multiple background transactions which may cause hindrance, performance hindrance to your web application. So apart from the basic web transactions, most applications run background. It could be a scheduler task, it could be a report generation task which could be running in the backend. So it is important to keep a track on those background transactions, which is again an important perspective. So you could pinpoint the app errors. So application manager collectively collects the errors which is happening inside your web application with respect to a specific user-based transaction, and we show you the response time, average response time for those specific errors, and you could drill down to a specific error to see the stack trace. And this is how the stack trace of error transaction looks like. So this would be quite helpful for DevOps and application stakeholders, the developers perspective. So let me show you the other topic for today, that is the APM Insight custom instrumentation. So apart from the basic APM Insight, Application Manager APM Insight provides you an other additional option wherein you could use custom instrument the specific blocks of your app code. Say for example, you just wanted to test the login functionality of your web page. So in those specific case, you know that your the method which is used for the login transaction. So all you have to do is just specifically instrument that method to see the invocation instead of instrumenting the all the methods automatically which is used by the app manager. You could also trace the specific method level details using this option. So additional insights for Java-based web application. So this metric is commonly specifically for Java-based web application. So we all know that this Java JVM, the Java Virtual Machine, is an abstract computing machine which enables a specific system to run a Java program. So it is important to keep a track on this JVM metrics, which gives you clear information of how well your JVM is performing. And also, few KPIs in terms of JVM would be CPU usage, heap and non-heap memory, JVM classes count, garbage collection details, thread details, and config details. So this is going to be the garbage collected information. Garbage collection, in fact, makes your Java program efficient because this garbage collector removes the unreferenced objects from the heap memory. If you have any performance issue, it is highly recommended to perform the garbage collection in a regular time intervals to reduce those kind of performance issues. And next would be as we all know that the production grade web application is highly complex and it is distributed. It is using a multi-threaded applications. So Java application in production can cause hundreds or thousands of threads running in parallel. So when an issue is detected, the JVM is taking very high CPU usage. The next question would be which thread is causing the CPU spike, and the immediate next question would be which code snippet the thread is executing. While it is important to get this information in a more real-time perspective, Applications Manager gives you those details. So let me switch back to the UI and show you the details from the product. So let me just choose the APM Insight and let me choose the traces tab right here. So as you could see here, this is one of the transactions which is categorized as slow based upon the response time. And as I shown you earlier, you could find the method which is being called and the internal code invocation along with the SQL statement which is being executed, and the count and duration for the specific invocation along with the percentage, and most importantly the trace details for the specific transaction along with the exclusive and total time in milliseconds, and along with the SQL statements with the timestamp, execution time, and the actual query in a parameterized way. So we don't show the confidential information right here along with the query count. And going to the JVM tab, So you have the JVM CPU usage and the runtime memory. So it is important to keep a track on this runtime memory. And you could see that the use memory is so and so percentage difference, and the heap memory and non-heap memory. And there are again some components in those as well. And you could see the categories and garbage collected information. That's what we have discussed. And again, you can sort it based upon the total connection, current collections, and the current collection time information and threads information again right here. So it is important to keep a track on these peak threads and live threads and daemon threads, which gives you, if there are more number of daemon threads or peak threads, that's where in some of the cases your application might have a performance issue. So it is important to keep a track on this. So apart from this, for detailed level of generating a thread dump and heap dump, we strongly recommend to use our Java runtime monitor, which is one of the category which is available right here in the application servers category. So we use a specific method called JMX to fetch these details. And you can use, and tool itself can raise the thread dump or heap dump based upon the CPU utilization, and fewer level of automation can be done using that specific action. So a user has asked a specific question regarding that, and we will be discussing that during our question and answer session. So with this, let me switch back to the presentation and discuss about the next agenda topic for today. So based upon our existing customer request and the market trends and prospect request, we have enhanced our APM Insight to a whole new level, and this enhanced APM Insight will be available shortly. So this is how the data looks like, wherein we are planning to show new metrics, which will give you handled exceptions, total number of exceptions count, and apart from the basic details like request and throughput, you could also see the high level details like external calls and SQL statements. And this is how it is going to be. Here you could see the slowest method call details along with the external calls. If you have any dependency with any third-party services like any APIs or any external web service, so we show you those details in our enhanced APM Insight, which will be available shortly. So we almost came to the end of the session, and just a quick recap of what we have discussed today. So we have discussed about optimizing your application response time using the APM Insight solution, and measure the end user customer happiness level using our Apdex score. And also we have discussed about pinpointing the specific transactions which is causing slowness to your application, and analyzing those from the SQL statements, and using the stack traces how one can fix the issues. And also we have discussed your applications monitoring in terms of DBS perspective, and we have shown few metrics which would be quite helpful for DBA proactive monitoring. So I see a lot of questions being asked. So with this, I will hand over this session to one of our expert panelists, Arun. So he will be answering all their questions shortly. Over to Arun. Please stay tuned with